Welcome to doing Euler's method in Excel. So this Excel file is available to you. It's linked both for those of you in the Canvas shell. This Excel file is directly available to you. What we have here, this Excel file is already pre-built for initial condition 0, 1, and with differential equation -2 times y plus x cubed times e to the -2x. So we're going to do this now with the equation we were working with in the previous video. So the equation that we will now be using will be y prime is equal to -2y plus 3x squared times e to the -2x. Just switch that to a slightly darker color, hopefully. So from here, we can go ahead and do, and we have initial condition of y of 0 equals 2. And our job from here will be to approximate y of 0.5. Using Euler's method. So how we're going to use this Excel spreadsheet, we're going to put in our initial conditions. So x initial conditions should be 0. Our new initial condition for y is 2. Then our equation should be -2x. So we're going to use the A11 cell as x, sorry, -2y. So we'll use B11 as our y. So we have -2 times B11 plus x cubed. That's not what we want anymore. Instead, we want 3 times x squared, and then times the exponential e to the, and then the exponent should be -2x, or -2 times A11. From here, we'll hit enter. We need to enter 2 more equations. So in the second x cell, we're going to enter equals, then the previous x value, plus our step size. So let's start with step 0.1, as we did previously, and hit enter. And then here, we are going to enter B11, our previous y value, plus C11, our slope, times, and then in parentheses, our new x value minus our previous x value. You could enter your step if you want, that's fine. I just like to do this so that I only have to change one thing if I change this step. Now hit enter. At this point, we've programmed in all of the equations we need to. So from here, we can go ahead and I'm going to increase my font size. There we go. From here, we can go ahead and just let Excel do all the work. So we're going to click in the last box of the X column and just drag down however far you want. Click in the last box of the Y column, then click on the bottom right corner, drag down, and stop before the last X, and then click in the bottom right corner of that last one in the K column and drag down. And now all of a sudden, all of your numbers get adapted. So these numbers in the K column are your slopes. They should look familiar. The numbers in your Y column are the Y values, and then we have our X values. So at this point, we can see the y value at 0.5 is being approximated as 0.6951, which is precisely what we got previously. If we want to do a different step size, so here we had using step size 0.1, we got y of 0.5 is approximately more or less 0.6951 ... Now let's do this again using step size 0.05. So using step size 0.05, well, all we have to change is the cell where we put in our second x value. So let's change that step to A11 plus 0.05, hit enter. And then you do need to drag down one more time. And we get our new values. So going down to a y value of, or an x value of 0.5, we now have our approximate y value is 0.7403. So we can change that. So we have y of 0.5 is approximately 0.7403. We could do this again using step size 0.01 if we wished. So doing that once again, we just need to change our step. So clicking back into that second X cell, we have A11 plus 0.01 for our equation, hit enter. Then re-drag down, and we're going to have to go quite a bit further to get all the way up to 0.5. And then just to be safe, always go past the X value you're looking for. Our algorithm requires us to go just slightly further than we previously had, or than what we're aiming for. The Y values, you can stop just right at 0.5 for X. And so if we go all the way down, it resets. And so using step size of 0.01, we get a Y value of 0.5 is approximately equal to 0.7737. So as we saw in the previous video, the actual value is 0.78 something. So using smaller and smaller steps, we are getting closer and closer to the actual value. So this is using Excel to calculate, to perform Euler's method. You're welcome to use other technology as well. But this is an easy one and free.